The next category of interfaces I want to cover is the function category. On this slide, I'm showing 4 of the most common interfaces in this category. Each has a return type shown here as either T or R, which stands for result, meaning a result is expected for any of these. In addition to function and bifunction, there is also unary operator and binary operator. You can think of the unary operator as a function interface, but where the argument type is the same as the result type. The binary operator is a bifunction interface where both arguments have the same type, as does the result, which is why the result is shown as T and not R. This reminds us that the result will be the same type as the arguments to the methods. I've also included the type parameters with each interface name on this slide because I wanted you to see that the result for a function or bifunction is declared as the last type argument. For unary operator and binary operator, there is only one type argument declared because the types of the arguments and results will be the same. On this slide, I'm showing an example of a lambda expression which targets a function interface. This lambda expression takes a string S and splits that string on commas, returning an array of string. In this case, the argument type T is a string and the result R is an array of string. To demonstrate how to declare a variable of this type, I'm showing a variable declaration as well. Let's get back to the code and use some of these interfaces. There are 2 useful methods, one on list and one on the java.util.arrays class that I haven't yet reviewed, which I'll cover now. As with the for-each and remove-if methods, it didn't make sense to talk about them before understanding interfaces and lambdas. I'll use these as examples of 2 different interfaces in this function category. The first method is on list and it's called replace all. It takes a unary operator as an argument. Can you guess why? A unary operator takes one argument and returns a result which has the same type as the argument. By executing this kind of method, you're guaranteed to get back the same type you passed to it. So, as an example, you can pass an array element and get a transformed array element back, which replaces the current value in the specified array position. I'll again use my NATO alphabet list for this example. I'll execute the replace all method on list and pass it a lambda expression. This one also takes a single parameter, so I'll make that S for string. I'll execute the charat method on that, concatenate a dash, and then execute 2 uppercase on S, also adding that to the result. I'll print a separator line and then print my list elements. Let's run this. You can see A is for alpha. Remember that I removed Bravo earlier, and so I have C-Charlie, D-Delta, and E-Echo. With one statement, I can update every element in the array with a formula I pass directly to the replace all method. Let's look at the implementation of this method by control-clicking on it. This method uses list iterator because for each element, it's going to call the set method, replacing the current element in the iterator with a different value, the value that gets returned from the apply method. This should remind you that the list iterator gives us this option, meaning using set, which the iterator by itself doesn't, because it only supports removing elements. I hope some of these examples are starting to capture your attention and generate enthusiasm for using lambdas. They'll ultimately save you from writing a lot of unnecessary code. Getting back to the code in main.java, I next want to show you the setAll method on the java.util.arrays method. This one is similar to the list.replaceAll method, but it takes an int function. What's an int function? Can you guess? It's a function interface that has the apply method with an int primitive argument, and it returns any type, but when executed as part of setAll, the type will match the type of the array element. I'll create a new array of strings first and print the elements out using the toString method on arrays. Here I'm just creating an array of 10 strings and printing them out. Remember that this just gives us an array of 10 null references, and you can see that when I run this code. Next I'll use the fill method, which I have covered previously, and it just takes a single string and sets each element to that string. This time I'll fill the array with empty strings and again print that out. And now you can see I no longer have null references, but even better than the fill method, there's a setAll method that lets us use a formula to populate each element. This interface is different from the one in the list.replaceAll method, because instead of having access to each element, we actually have access to each index value in the array, so the parameter is an integer representing the current index of the array element. I'll invoke the setAll method on the arrays class, first passing it the empty strings array, and then include a lambda expression. The parameter is I, which traditionally is the way to refer to an array index in a loop, and on the right side of the arrow, I'm setting up a string that includes the number, I plus 1, and a period after that, and I'll again print that. Let's check the results. My array elements now include numbers in their strings. Let's take a look at the setAll method. I'll control-click on it. This opens the arrays class, and you can see the setAll method. You can also see it takes an array, and the second parameter is an int function interface type called generator. Instead of an enhanced for loop or an iterator, it's using a traditional for loop, iterating over every element in the array. It then sets each array element to the result of the apply method on the generator. For my code, this is the lambda expression which used index to populate each array element with a number, starting with 1, not 0. Okay, let's get back to the main method and explore what else we can do in that lambda expression. Because Java gave us switch expressions, I can use a switch expression directly in my lambda expression. I'll copy these last two statements and paste them right below. I'll add a new line before the closing parentheses on the arrays.setAll statement. I'll add a simple switch expression as part of this lambda expression single statement. I'll add plus, then switch with I. For case 0, I want to add the literal string 1. For case 1, the literal string 2, and for case 2, the literal string 3. Then I'll add a default, which will just return an empty string, and running that code. You can see I'm able to fill the array with values using a switch expression in my lambda. Pretty neat. As with anything, you'll want to achieve a balance between the readability of code and its succinctness. This lambda could be a candidate for a method somewhere. I just wanted to show you that there's really no limit to what you can do when a method supports these functional interface types. Okay, those are two useful methods you're sure to have opportunities to use, and two examples of interfaces that fall into the function category. This leaves us with one more major interface category left to discuss, and that's the supplier. The supplier interface takes no arguments, but returns an instance of some type, T. You can think of this as kind of like a factory method. It will produce an instance of some object. However, this doesn't have to be a new or a distinct result returned. I'll explain that in a minute. In the example I'm showing you on this slide, I'm using the random class to generate a random integer. This method takes no argument, but lambda expressions can use final or effectively final variables in their expressions, which I'm demonstrating here. The variable random is an example of a variable from the enclosing code. Let's get back to the code, and I'll demonstrate code similar to this in my main method. In previous videos, I used an instance of random to pick randomly generated names from an array of names. That's what I want to do here, but using a supplier lambda expression. First, I'll create a method on the main class, making it public and static. It'll return an array of string, and I'll call it randomly selected values. It has three parameters, an integer count, an array of string I'll call values, and a supplier interface type that takes an integer. This method is going to return an array of string with the same number of elements that are passed as the first argument. It'll use the second argument to get a value randomly picked from that array. It will use a supplier interface to get an integer to use as the index to pick the name. Now let me add the code that does all this. Selected values is another array of string and will have count elements. I'll loop from 0 to 1 less than the count. I'll set each element in my new array to a corresponding element from the array passed to this method. However, I'll get the index from the supplier argument, the lambda expression in other words, that gets passed. Finally, I'll return the newly created array. Back to the bottom of the main method, I'll now set up my names array with names Anne, Bob, Carol, David, Ed, and Fred. I'll set up a local variable, an array of string, and call that random list. I'll assign the result of calling my new method randomly selected values. I want an array of 15 strings back, so that's my first argument, 15, and I'll pass my list of valid name entries, and finally I want to pass a lambda expression. This lambda has no arguments, so I need a set of empty parentheses before the arrow. After the arrow, I'm going to invoke next int on a new random instance, passing it 0 as the first possible value and names .length as the exclusive ending boundary. So this will give me an integer between 0 and 5. I'll then print my list of random names, and if I run that, I get an array of strings that contains 15 names randomly selected from my names array. I want you to look at this lambda expression closely. This is the first time I've showed you an example that had no argument at all. In this case, an empty set of parentheses is required. In a lambda expression, on the left side of the arrow, you can have empty parentheses like we do here, which means no arguments. You can have a single variable name, which means there is a single argument. You can have a type single variable, but that needs to be in parentheses, and multiple arguments also need to be enclosed in parentheses. This slide shows the many varieties of declaring a parameter type in a lambda expression. Parentheses are required in all but the one case, where the functional method has a single argument and you don't specify a type or use var. When using var as the type, every argument must use var. When specifying explicit types, every argument must include a specific type. This ends my introduction to Java's functional interfaces. There are other interfaces which aren't in the java.util.function package that are considered functional interfaces, one of which is comparator, which I've already covered pretty thoroughly. You'll learn about others as we progress through the course, which are specific to other topics. These 4 sets of interfaces alone cover a lot of ground and provide endless fertile ground for usage. In the next video, I'll give you a challenge to test what you've learned about lambda expressions and functional interfaces.